Before going to the main organic chemistry lesson, we need to revise the basic concept of chemistry first. Firstly, you must understand the particle characteristic. The particle is the small part of matter. It classifies into atom, molecule, and ion. The particle characteristics are described below in relation to the atom, molecule, and ion. Now, we come to the atom. The right side is a general vision of an atom. To let you know, the atom is the smallest unit of matter, consisting of a dense spherical original nucleus surrounded by electrons. The proton has positive charge, while neutron has no charge. For additional info, atomic number is the number of protons in an atom, while atomic weight is approximately total number of protons and neutrons in the atom. Meanwhile, the electron is light and negative charge. It moves Britain and occupies in the shell. The Britain movement of electron is influenced by the attraction force between electron and nucleus. Why the electron is not included in the atomic weight? This is because the electron weight is very light. Even though electron moves freely around the nucleus, the electron still has movement restriction due to attraction force of nucleus and electron repulsion. This seems that it is important to specify the electron distribution in the atom. Two general terms are introduced relating to electron distribution. The first term is orbit, also called as shell. It is a circular region where the electrons found around the atom. The higher number of shells, the larger the atomic size, which influences the strength of atom characteristics. Another term is orbital. Orbital is a region where high probability of electrons moving around the nucleus of the atom. It represents high electron density region in the atom and also describes the wave-like behavior of electrons in 3D space. There are four kinds of atomic orbitals depending on the shape: S, P, D, and F orbitals. If we look at the diagram below, the S orbital has spherical shape, while P orbital has dumbbell shape. Orbital almost affects molecular structure and bonding. The diagrams below also show that the electron arrangement and electron configuration. The electron arrangement describes how electrons arranged in each shell, starting from inner shell. The carbon has total 6 electrons. The first shell contains 2 electrons, and the second shell contains 4 electrons. Hence, the electron arrangement of carbon atom is 2.4. Besides, the Lewis structure describes the location of electron valence. It illustrates the single 4 electrons located around alphabet C, which represents carbon atom. Apart from electron arrangement, electron configuration describes how the electron moves in each orbital of atom. The electron configuration of carbon atom is 1s2, 2s2, 2b2. It means that the first 2 electrons locate in the s orbital of first shell. Another 2 electrons locate in the s orbital of second shell, while the remaining 2 electrons locate in the p orbital of second shell. From the diagram, It illustrates that 2s orbital is larger than 1s orbital. The electron in p orbital can move freely at either s, y, or z axis. The periodic table of elements collects and arranges all elements based on proton number, electron arrangement, and orbital. In the table, each row represents the number of shells in the atom. Meanwhile, each column represents the valence electron and the same chemical properties of element. So far, 4 atom characteristics focus on the chemical structure and reaction. First, electron valence is the number of electrons occupied in the outermost shell in an atom. Second, element valence shows the number of the atom or group typically bonded to a particular atom. For example, nitrogen has 5 electrons in the outermost shell, so its electron valence is 5. The nitrogen has one lone pair of electrons and 3 remaining electrons in the outermost shell. The remaining electrons can bond to 3 different atoms or groups with single bond. Hence, nitrogen has 3 element valence. Apart from that, electron negativity is the tendency of the atom to receive the electron to form negative. Its characteristic constant is opposite to electropositivity. This diagram shows the Pauling scale that describes electronegativity in the periodic table of elements. The highest electronegativity is fluorine at top right corner, while the lowest is francium at the bottom left corner. From left to right, in the same row and same number of shells, higher number of protons increase positive charge of nucleus and then reduce atomic size. The nucleus has higher strength of attracting electrons towards it. Thus, the electronegativity increases. From top to bottom, in the same column, higher number of orbits results in greater atomic size. The larger distance between outermost electron and nucleus, and greater inner electron weakens nucleus to attract the outermost electron towards it. This phenomenon called screening effect. Thus, electronegativity decreases. Throughout this lesson, I list out the properties of common organic compound composition in the aspect of atom symbol, proton number, electron arrangement and configuration, electron valence, element valence, electronegativity, and also stable ion form. You can evaluate other element properties by referring to the periodic table of elements and Pauling scale.